Taking over for Alicia. I'm a postdoc with CSAFE at ISU. And welcome everybody to our Center Wide Webinar. First things first, we have a couple of announcements. First, we have another Center Wide Webinar next Monday, March 5th at 12:30 Central Time. This is going to be on footwear impression evidence examination, overview, challenges, research, and the future. This is going to be by Leslie Hammer from Hammer Forensics. We also have the CSAFE Conference on Forensic Statistics and the Law. That's going to be at the University of Virginia Law School in Charlottesville, Virginia on March 26th. This is a free event open to the public and no registration is required. And contact Brandon Garrett at Virginia for more information on that. And finally, we have a save the date for the 2018 All Hands meeting for CSAFE. That's going to be June 11th through the 13th at Iowa State and here in Ames, Iowa. And we will have more information about that soon. So today's presentation is a panel discussion with NIST researchers Steve Lund and Hari Iyer and the CSAFE team on the likelihood ratio. So first we're going to have Steve Lund and Hari Iyer from NIST speak about the role of expertise in moving from crime scenes to verdicts. And then we're going to have Hal Stern as our first panelist, as talking about what sensitivity analysis tells us about the likelihood ratio approach to forensic evidence. Hal is a professor of statistics at University of California, Irvine. Next, we're going to have Dr. Bill Thompson on what do likelihood ratios mean to lay audience. So he's a CSAFE researcher also at the University of California, Irvine. Then we are going to have Professor David Kaye on evidence, law, and the likelihood. And after David Kaye is done, we will have an open discussion. Please hold all your questions until the discussion period. Please put them in the chat instead of using your microphone. I think that's it. Am I missing anything? Okay, so I think we can go ahead and get started when Steve and Hari are ready. Thank you.
We are briefly experiencing a little setup difficulty here. Just 1 second.
Can you hear us?
Yes.
Okay, thanks.
I'm trying to get a full screen of the PowerPoint presentation, but it's... Any suggestions?
Maybe they see the full screen.
Maybe they see the full screen. All right, well, just try this and you tell me if you can see. What do you see?
We see a PowerPoint slide.
If you can click the little monitor icon next to the minus at the lower right of the screen, that will take it full screen.
Click the...
A little bit, nope, the other way. Next to the minus, there you go, click that. Good.
Okay, thank you. Sorry for the delay. So Hari and I are here today and are excited to participate in this panel discussion. I'd like to start with a disclaimer that the viewpoints expressed here are our own and are not intended to reflect the viewpoints of anybody else at NIST. And also, we are only discussing what makes sense to us, and we're not trying to make any claim that these are new perspectives. We'd like to start with the flow of information as we perceive it, kind of a course outline of the flow from going from crime scenes to reaching verdicts. So when a crime has been committed, some trained professionals report to the scene of the crime, where they gather observations and collect evidence from the scene. which then feeds into part of a broader investigation where narratives are constructed for what had happened at the scene of the crime and possibly identifying a person or persons of interest. When forensic examination occurs, it involves the comparison between evidence collected from the crime scene in the context of these considered narratives. And all of this information is summarized into a report, which is then passed along to the legal community, where maybe a district attorney uses that information to decide whether or not, or whether to drop the case or to press charges, or defense attorneys, and decide whether to advise their clients to enter into a plea bargain or proceed to trial, where trial then involves still more people, being the judge and the jurors, who try to rely on the information gathered from the forensics community or forensic experts to reach a true, just verdict. So we have the information originating with the parties over here on the left, the forensic scientists and investigating professionals, and that information has to be given to a collection of other people to be used in reaching just decisions. The vehicle of transfer for this between those parties is a report or the testimony, which historically has been given with a punchline of a conclusion, which may have been expressed as a categorical conclusion, such as an identification, an exclusion, or inconclusive. And more recently, the broader scientific community has looked at this process and raised some questions like, are these processes validated? Do we know what the error rates are for them? And the statistical community has been maybe a little more direct in expressing concern with a reliance on categorical conclusions for informing additional parties, and has offered the suggestion of using likelihood ratios instead. So just very briefly, we'd go over a reminder of what a likelihood ratio is. So it's an effort to characterize how strongly the considered evidence, let's call that E, affects one's perception regarding which of two competing narratives or hypotheses are true. So just as a cartoon illustration, suppose we have a background information that Hari was seen walking away from a broken window in one of the houses in his neighborhoods, and we're considering two potential narratives, the first being that Hari broke the window, or the second narrative being that someone else broke the window. So just given this information, we may form some initial perception regarding how confident we are that narrative one is true, being that Hari broke the window. And then subsequent information may be collected, or subsequently additional information may be collected, and suppose that information is when Hari's clothing was examined, 3 glass fragments were found on his shirt. So this is now new information, and our question is, after considering this new information, how does the perception change regarding the truth of narrative one? And the LR, the likelihood ratio, is an effort to characterize how strongly this new information changed that perception, and is computed as the ratio between the chance of encountering this evidence if narrative one were correct versus that chance of encountering the evidence if narrative two were correct. So this is a ratio of two, we can say, probabilities. And so it can have a value anywhere from 0 to infinity, where 0 corresponds to the evidence could not occur if narrative one were correct. So we'd get a 0 for this ratio if this top part were 0. And infinity, on the other end of the spectrum, corresponds to the chance of encountering this evidence is 0 if narrative 2 were correct. So you just can't see this evidence if the second narrative were correct. And kind of the midpoint in terms of weight of evidence corresponds to a likelihood ratio value of 1, where the observed evidence is equally likely under either narrative. And Bayes' formula tells us how to piece this information together with pre-existing beliefs, where we would express our initial confidence in the truthfulness of narrative one before considering the new information, then we would use the likelihood ratio to update what our belief or degree of confidence had been. So this is kind of characterizing how what we learned from the evidence has impacted our belief to arrive at posterior odds of what you believe now. So the statistician, when he hears the word conclusion, is mapping that to the Bayesian framework for decision-making under uncertainty. And under the Bayesian framework for decision-making under uncertainty, says that making a reasonable decision requires considering how confident one is in each of the possible narratives after processing whatever information is available to them. So this is referred to as a posterior probability. One also has to consider what the cost or benefit under each of the potential scenarios that might be true for each of the decisions that you could make. So there's a perceived costs of what you might do. And Bayes' rule also says that we can't get to a posterior belief without having some initial belief, some starting point, which is then updated by the newly considered information, which in this context would flow from the gathered evidence and observations. And the argument from the statistical community is that the forensic expert should be focused only on the information contained in the evidence, so that the perceived costs and the prior beliefs are really out of bounds from their domain of expertise. And so if they're out of bounds and shouldn't be considered under the Bayesian framework, we can't really arrive at posterior beliefs or final decisions. And so for this reason, the weight of evidence or the likelihood ratio takes center stage. And the reason that Hari and I were invited to participate in today's panel discussion is from a paper that was published in the Journal of Research at NIST titled "The Likelihood Ratio as Weight of Forensic Evidence, a Closer Look." And despite our best efforts to an attempt to write something clearly for a fairly broad audience, the response from the community has been a little bit of frustration, but mostly confusion. So our understanding of the purpose of our involvement in today's panel was to give us an opportunity to clarify our intent, and for those who have encountered the paper to have a forum to ask questions. So the intent from our side when writing the LR paper was first prompted from what we perceived to be claims made by others. And so the initial claims that we saw were that Bayesian reasoning explains why we should be concerned with examiners providing categorical conclusions. And additionally, that the LR framework is a helpful, natural, and logical way to consider evidence. And we have no objections to either of these claims. We felt like the statistical forensics community often takes it a step farther and saying that Bayesian reasoning or logic has shown that experts should be communicating their findings using a punchline of a likelihood ratio characterization. Or a subset of the community has even expressed a desire for the forensic expert to characterize their assessments using a single value, a numeric value for the likelihood ratio as one number. And it's these points that we attempt to disagree with in our paper. Additionally, in our paper, we express our viewpoint that the trustworthiness of a likelihood ratio, if we're to use it to inform other people, is unknown if we haven't examined the influence of our assumptions. So in particular, it's not sufficient to declare just what our assumptions were. We have to find out how dependent the result we're arriving at is on the assumptions that were made before we can know what the trustworthiness or the fitness for purpose of an LR characterization is. Additionally, we raised the question, and we consider it still to be an open question, of our likelihood ratio is the best presentation of information to help the audience reach just decisions? Or could it be that this is not the optimum peg for the whole? we would like to see increased attention given to developing effective descriptions of what the expert's empirical knowledge are, and we think this is worth further study. So those are really our punchlines to the paper as we see it, and I'd like to revisit that in a little bit greater depth in hopes to prompt conversation and understanding. So I'll begin with assumptions and uncertainty in LR characterizations. So the forensic professional has gathered some evidence and observations, and if the target is an LR characterization, they have to translate that information into a likelihood ratio value. And probabilistic interpretation always depends on some form of a model, and that's where a statistician might come in. And in Stat 101, you might have a particular model in mind that you apply to this collection of information, and you arrive at a particular value. And maybe you do some sort of uncertainty characterization that gives a range of values within the context of the assumptions made for this modeling effort. And subsequently, you may have some test that you use to assess whether or not this model is reasonable. And if this model has passed that test, the declaration is, okay, this likelihood ratio value we've obtained is reasonable. George Box has pointed out in several different notable quotes the risk of becoming too focused on one particular model. And maybe a slightly less popular quote than the all models are wrong, some are useful, are that statisticians, like artists, have a bad habit of falling in love with their models. And if you've fallen in love with your model, that may cause you to stop looking around at alternative possibilities. But if you've been around the game for a while, you may start out by considering a broader class of models. So somebody who's been thoroughly trained in statistics may have an initial set of models or a collection of models or some conceptualization that there's more than one way to translate this evidence observations into a value for the likelihood ratio. And may also understand that each one of those models can give a different value, and that multiple of those models can pass the reasonability test. And they may also have an awareness that there's not just one way to assess whether a given model is reasonable. There are different perspectives and different tests that one could use, and depending on what test you use, that defines a different subset of your models that are reasonable. So the range of reasonable results for the likelihood ratio is dependent both on what set of models you're willing to consider and on what criteria you're choosing to implement or impose for deciding when a model is reasonable or not. And this setup is what we've been referring to in the paper as an uncertainty pyramid, which here would be better represented as being tipped on its side. So again, the range of reasonable results for a likelihood ratio characterization is dependent on how strict we are in determining whether a model is reasonable or not, as well as the class of models that we're willing to consider. So one option, if we were to be using likelihood ratio characterizations, is to try to pass all of this information along to the juror. So we try to explain what models were used, what plausibility criterion were imposed, what the corresponding range of results are under each of those. But the concern in the community is that for a lay audience, this will be met with confusion. So an alternative option is to translate using our favorite model to a single value of the likelihood ratio, or possibly looking at some uncertainty within the assumptions made for that model, as well as to articulate that this model has been checked to make sure that it's reasonable, and to not provide any of the other information that there are other models that are also reasonable or that there are other ways to assess whether or not a given model is reasonable, and to stamp it with the seal of approval from the statistician, saying it's been well trained and this is, you know, their area of expertise, so we can have confidence in the result provided. But even under this setup, some of the research that Bill Thompson has executed has shown that the jury doesn't always understand a likelihood ratio characterization, even when we're trying to get down to a single model and a single value associated with that. So from our perception of what the message from the community has been, there's been a lot of focus on likelihood ratio characterizations, and our viewpoint is that providing an LR characterization should not be assumed to be the default goal of an expert, but rather as a leap to be made with some caution, where they're considering what is the risk? Is there a sufficiently clear answer to provide for the weight of evidence, which would be informed by looking at what does the uncertainty pyramid look like? Is the value we're arriving at heavily dependent on the assumptions that were made, or can we, does any path taken lead to a very similar result? Does the message communicated by a likelihood ratio characterization misrepresent the information that's actually available? Will the audience understand what is being said here? And what is the benefit of taking an additional step to characterize the meaning of this evidence, as opposed to focusing directly on communication strategies based on the demonstrable information collected by the experts? So we would like to see increased interest in the community, or strategies developed for styles of presentation that can adequately transfer the information directly collected. And this was inspired by some of the interpretations offered for the conclusions or reports provided from the experts. So the Association of Firearm and Tool Mark Examiners, in trying to define what an identification is, refers to the extent of agreement exceeding that which can occur in comparisons of tool marks made by different tools, and being consistent with the agreement demonstrated by tool marks known to have been produced by the same tool. Or more recently, coming out of the United States Army Criminal Investigation Laboratory, the Defense Forensic Science Center has implemented use of FR-STAT, which has an algorithm for measuring the strength of correspondence between two fingerprint impressions, and characterizes the meaning of that as, or through the probability of observing this amount of correspondence being so many times greater when the impression is made by the same source rather than by different sources. And under either of these, it seems like the expertise, which Webster's dictionary defines as expert skill or knowledge in a particular field, the skill being a success in discriminating between narratives, where in the context of the previous language on the previous slide is between mated or non-mated pairs, so pairs of patterns made by the same instrument versus pairs of patterns where the two patterns were made by different instruments. And the knowledge corresponds to a familiarity with the performance of the chosen method of evaluation in known instances. And this applies whether it's an examiner opinion, which could be informed through things like the black box study or blind testing, blind proficiency examinations of the community, or a computer algorithm. So in order to make the interpretations of the conclusions stated on 2 slides ago, the experts must be knowing what method to use in a given situation, as well as having familiarity with when this method has been used in the past, where ground truth is known, and considering how relevant each of these instances are to the case at hand, and how this method has performed in those instances. And when the community has found those answers to be satisfactory, these detailed questions are often replaced with the term validated. So they say, we're using this method and it's been validated. And Hari and I are concerned with the use of the word validated in the same way that we're concerned with the phrase training and experience. Not that validation investigations and training and experiences aren't helpful, but they have to be transparent. That's the information that an audience really needs in order to adequately interpret the result of a particular comparison. So the expert is claiming to have a clear view of what the meaning is based on a historical performance of this method. But if we just say the method has been validated, or I'm using my training and experience, none of the information that the expert is using to interpret the meaning of the output is actually shown to the audience that needs it. So it's like bringing somebody to a baseball game, and instead of them getting a clear view of what's going on so they can form and shape their own perceptions, all they see is a metal pillar. So we would like for the term validated to not be used, and instead to keep focus on asking the questions directly of when this method has been used in the past where ground truth is known, and how relevant each of the instances are to the case of hand, and how the method is performed in those instances. And to really make this part of the central message when reporting or providing testimony to another audience. And we'd like to see methods developed for the most effective ways to really provide this information directly. So as just a very introductory effort, suppose we're considering fingerprint examination, and an expert arrives saying, here are the collection of, I'm going to use algorithm A. And for algorithm A, I've conducted 798 total comparisons where the two fingerprints were made by the same finger. And I've conducted 634 total comparisons where the fingerprints were made by different fingers. And in each comparison instance, the algorithm outputs a number measuring the degree of similarity. And if you like, we can start to show, here's a mated comparison that produced this score, right? And here's another mated comparison that produced this score. And so this histogram is summarizing the scores that I obtained when I conducted these 798 total comparisons. And similarly, I could do the same thing within the non-mated. So I'm representing the history of the usage of this comparison method in instances where we knew what the truth was. And now, when a particular case comes up, we recognize that not all of these comparisons are equally relevant to the case at hand, which has a partial question. So we return to our complete portfolio of reference comparisons, and we reweight them using some criteria for how relevant each of these are to the case at hand. And this changes how much information we have about the performance of the method. So under this cartoon characterization, we went from having 798 total comparisons to, for this particular case at hand, having roughly the equivalent of about 127 comparisons, because some of the comparisons in our reference database aren't fully relevant to the case at hand. And then using this filtered database, we can look at what was the result returned from the algorithm in the context of the relevant component of our database. So if the comparison between these two patterns resulted in a score of 13, we can now go look at what proportion of the mated population returned a score of 13 and what proportion of the non-mated population returned a score of 13. But that's not the only information we could have. We could also start considering alternative sources from our database and look at the behavior as scores returned from those as well. And this really starts to portray directly the information available to the expert in this assessment. So like I said, it's just a cartoon as an illustration of where we'd like to try to see further development, because we feel that this information is critical for the audience understanding it's understanding the meaning of the result of a comparison process in a particular instance, and that this information would facilitate the audience reaching an informed assessment for the probative value of a particular result. So really that the student has become the master and is capable of understanding things for themselves. So as our final wrapping up, our key points here was we're looking for the best presentation of information to help recipients reach just decisions. We agree that while Bayesian reasoning may explain concerns with examiners using categorical conclusions, we don't feel that Bayesian reasoning has shown likelihood ratios to be the best ways for experts to communicate the information available to them. We feel like if likelihood ratios are going to be used, it's really important to have a framework for assessing the trustworthiness of a likelihood ratio assessment. And we'd like to see further efforts in the community to effectively describe what the actual collection of empirical results known to the forensic community are. Thank you for your attention.
Thank you. Hal, do you want to get started?
Yes. Let's see. Okay, can everyone hear me? Or can Iowa State hear me?
We can hear you and see your slides.
Okay, great. So let me get the slideshow started. And let me take it out of presentation mode. Okay, great. Thank you to Steve and Harry. I think they gave a great presentation. I was asked to talk a little bit about, from the statistician's perspective, the likelihood ratio. And what I'm going to talk about is two things. One is some reaction to the paper that Steve and Harry wrote, which I like much of very much. And I'll get to that. And then some more general thoughts about likelihood ratios. Like Steve in his introductory remarks, a lot of what I'm going to say is not specifically me, and it benefited from tons of conversations over time. I'm not sure why that message is there. I don't know how to get rid of it. Okay, good. So Steve introduced Bayes' theorem and the role of the likelihood ratio in the formula. So I'm not going to spend any more time on that. On the Lund and Iyer paper. Okay. One is from the Lund and Iyer paper, and it is the notion that the expert is, in providing a likelihood ratio, is kind of throwing some information into what a normative Bayesian decision-making paradigm might suggest is the purview of the trier of fact. So the jury, say, is entitled to their prior opinion to form their own impression of the evidence and posterior. So that's one of their points, and I think that's one way of looking at this. By and large, people who are advocating the likelihood ratio, and I include myself in that group, are not necessarily thinking that way. Instead, thinking that the likelihood ratio is perhaps a logical way to summarize the evidence, and I'll come back to that. A second point that's worth noting in the context of the Bayes' theorem and the likelihood ratio is I've been part of several discussions in which the question comes up of what do we expect of the expert? Should they provide the likelihood ratio, or should they in fact step in and provide the posterior odds? So some of the statements that are proposed to be making is, I've looked at the evidence, and based on this evidence, I'm reasonably confident that this person wrote the signature, or that these two items match. That moves the expert testimony from the likelihood ratio to the posterior odds. And that, I think, is problematic for many, including myself, in part because if you are trying to make a statement about the posterior odds, you must, by definition, have assumed something about the prior odds. And so where they came from is critical. I think the great point that I enjoyed in Steve and Harry's paper is this notion of people talk about the likelihood ratio, but I put the in quotes here because there's not a single likelihood ratio for a particular set of evidence E. And the likelihood ratio can depend on lots of choices. Their paper and much discussion focuses on the data and models that we use. And as they emphasize in the paper and in the presentation today, two key ideas, if you are advocating a likelihood ratio approach, are transparency and sensitivity. So I thought what I would do is talk a little bit about the example they use in the paper, because I thought it was very nice and very helpful, and then some of the lessons that I take from it for using the likelihood ratio. So just as a reminder, if you've read the paper or if it's been a while, they look at the example of glass. So there's glass fragments at the crime scene, glass fragments from a suspect, and a desire to assess the evidence that these two sets of fragments came from the same glass source. And the key to their approach, or to the approach that they describe, the key to the likelihood ratio approach, is to think about how much variation you might expect to see in the glass fragments or in the specific refractive index measurements of those glass fragments from repeated fragments within a single source, and then how much variation you might see between glass sources in the population. And so they show these data in their paper. The top histogram here is what I'm calling the between distribution. So these are measurements drawn from different panes of glass, representative samples from different panes of glass. And you can see the range, and it's not a particularly standard normal distribution or anything like that, so that becomes one of the challenges. The bottom picture is the sample of, I think, 49 measurements from within a single glass source. Something to draw your attention to is the different scales on the horizontal axes here. So there's a lot less variation within a source than between a source, and I attempt to show that here. These are not perfectly matched, but just in using my own resizing tools here, I have the same picture on top, and on the bottom, I've rescaled on a different axis that matches the top, so you can see how little variation there is within and how much between. So in talking about sensitivity, or making sure that we consider a range of models, Hari and Steve present one way of thinking about what other distributions are plausible. So this is the within data, and I'm not going to go through this picture because there's not a ton of time, but the notion is for the within data, it is kind of single peaked, and so maybe you think it's a normal distribution, but there are lots of normals that are consistent with the data, and that's what's attempted to be portrayed here. Any normal curve that runs between the two black lines is consistent with the data by one definition. And so the green and the red are two examples. The red distribution is very tightly clustered around the average. The green less tightly clustered around the average. And these are all plausible. And so they go from there to say, let's compute the likelihood ratio. And so there's a couple of pictures here. They can be a little confusing to work through. But on the left, what you see, each dot is a likelihood ratio. And each likelihood ratio is being computed under a different model. And in fact, they're basically a combination of how do I choose to model the within a single pane of glass variation? That's kind of the color of the dots. And then how do I choose to model the variation between sources? And that's kind of the horizontal axis here. And there are a few things to note, right? So one of which is, in this particular choice, this seems like lots of likelihood ratios, but everything here is normal on the within, and everything here is what's called the Gaussian kernel estimate on the between. The likelihood ratio jumps around quite a bit. Most, not all, but most of the dots are in the range from 100, likelihood ratio of 100, up to 1,000. So that's where most of them sit. The interesting thing is there's a pile down here that's quite small and near 1. And so a key thing that I took out of the paper is it's important to think about what we believe are plausible distributions, but that's a really itself a hard question. And if plausible is everything under the sun, the likelihood ratio might begin to lose its effectiveness. But it's important that plausible be wide enough that reasonable people can agree about it.
Al, can you start wrapping up, please?
Yep.
Thank you.
All right. So on the right is an example of this where they take more and more plausible distributions and get wider and wider ranges. So I was going to wrap up with 2 comments. One is there's been a lot of controversy around the Lund and Iyer paper, which is the basis for this. And the reason in part is because many people in the practitioner community have said statisticians are still arguing with each other, and that's a sign that the likelihood ratio is not currently the direction to go or not the right direction to go. And I think it's important to emphasize that there's much we agree on. The need to consider multiple hypotheses, the need to assess the likelihood under different hypotheses, and the desirability of avoiding conclusion language that seems to imply certainty in the decision. And so I summarize by putting up what I think of as the main advantages of the likelihood ratio and the challenges. Talked about the challenges being how to explain this, and that the likelihoods may be difficult to construct, and that there's a lot of sensitivity. But for me, the advantages are very strong. They make us think explicitly about what we're saying about the data. They make us think about more than one hypothesis. And that's why I continue to think it's an important direction to work on. So thank you.
Thank you. All right, Bill, take it away.
Can you hear me?
Yes, we can hear you.
All right. I know we're a little bit behind, so I'll try to talk quickly, and I have no PowerPoint slides. You'll just have to hear me talking. I want to start by saying that I have been following this debate for some time, and I really appreciate the evolution of the debate about the Lund and Iyer paper. I think when it first came out and when I first looked at the paper, and particularly the NIST press release, I, like many people, said, holy cow, what are these guys talking about? Over time, as we've listened to them, I think we've come to understand the paper better and really appreciate that they're making extremely important points about the need to recognize uncertainty in likelihood ratio calculations. I think they've also become much better at articulating their position. So we're seeing some refinement and greater nuance to this discussion, which I think is really good. I was asked to talk about how lay people understand likelihood ratios and alternative presentations. And so I'll try to quickly review my thinking on that. I think it helps to start by considering what we mean by understanding something in this area. We're talking about a situation where an expert is helping a decision maker evaluate 2 hypotheses or 2 narratives. The decision maker, which may be a jury or a prosecutor or a police officer, is trying to decide between 2 narratives that call them A and B, and an expert's brought in who has some expertise in distinguishing between those hypotheses. The expert necessarily is going to have to think about the likelihood of the observed findings, whatever observations the expert makes on the evidence. The expert, in order to evaluate the evidence, is going to have to think about the relative likelihood of those observations under the alternative hypotheses. So the expert's going to have to be thinking, well, what's the probability of what I see if it's A, and what's the probability of what I see if it's B, and then use that to reach some conclusion. And how to communicate the conclusion? Well, in some ways, a likelihood ratio is a very straightforward way to communicate the conclusion. The expert simply says, well, I think my observations are X times more likely under narrative A than narrative B, so that gives some support to narrative A. And that's a straightforward way to communicate the expert's thinking, but it requires the decision maker to engage in some cognitive work to know what to make of it. I mean, the expert doesn't want to know about the likelihood of the evidence under the hypotheses. The decision maker doesn't want to know about the likelihood of the evidence under the hypothesis. The decision maker is trying to decide which hypothesis is true. Okay, and so some people think we should just give decision makers what they want. If the decision maker wants to know whether it's A or B, why not just have the expert make a decision and tell the decision maker? So the expert can come in and say, the expert can evaluate the conditional probabilities and the relative likelihoods, but then make a decision and just say, decision maker, it's A, or it's very probable to be A, right? Don't worry your little head about B, it's A. And some people say, isn't that simple? It's very simple. In one way, in one level, it's very easy to understand a conclusion like that, at least to understand what it is that the expert's saying. The expert's saying it's A. But if we're asking, does the decision maker really understand? I think we mean more than does the decision maker understand what the expert's saying. I think we need to think about whether the decision maker understands the basis for the expert's decision and can evaluate the logic of the reasoning and whether the conclusions make sense. The decision, the simple decision is maybe, it's easy to understand the expert's statement, it's A, but how much weight to give to that statement may vary a lot depending on how the expert reached that decision. And that's not necessarily going to be transparent if the expert's just coming in and saying, it's A, I've decided. I mean, experts can reach a conclusion of A in different ways. One expert might come in and say, well, I think the prior odds of A are really high, and the evidence I observe seems a little more probable under A than B, so I'm going with A, right? That's very different than an expert who makes a careful evaluation and says, well, the evidence I see is extremely plausible under A, and as far as I can tell, it's virtually impossible under B. Probability of seeing what I see under B is negligible, or what, So, and the other thing is that an expert, to make a decision, is going to have to apply some decision threshold, and it's not necessarily clear to the decision maker what that threshold is, right? So to understand the decision, the decision maker has to understand the decision threshold. The decision maker may be relying on prior odds. If the expert doesn't agree, if the expert's view of the prior odds is based on evidence or considerations that the decision maker doesn't agree with, that creates problems also, right? So the issue can be quite difficult. As far as what research shows, let me just quickly go through that. I mean, there's one question is, will people give as much weight to something like a likelihood ratio as they give to a more categorical conclusion? So one concern is that if experts present likelihood ratios, people won't understand them and won't give as much weight as a simple statement like it's A. We're starting to get some evidence on that, and the evidence that we get from paired comparison studies suggests that people do in fact give quite a bit of weight to likelihood ratios, statements about strength of support. So I'm not as concerned as I used to be about people just ignoring a quantitative presentation. Another question is whether people are sensitive to variations in likelihood ratio. Do they appropriately give more weight to a high likelihood ratio than a low likelihood ratio? And Christy Martiri and her colleagues in Queensland published, or in the University of New South Wales, published some studies suggesting that people are insensitive to likelihood ratios in some circumstance. I think the evidence we're finding is that people do seem to respond to the level of the likelihood ratio, at least for DNA evidence and voice comparison evidence, and they may be insensitive for kinds of evidence where they just trust the likelihood ratio calculations anyway.
Please wrap up, Bill, if you can. Thank you.
All right. The final concern about likelihood ratio is that people may transpose conditionals. The expert is saying the evidence is more likely under hypothesis A than B, and people think the expert's saying hypothesis A is more likely. People do that a lot. We know that it's a problem. Whether the solution to the problem is to have the expert, in effect, present a posterior is, I think, is a question we'll have to think very carefully about. So as far as how well do people understand likelihood ratios, I think there are problems. We might, I think we need a lot more research on on how to explain them, how to explain these findings to people in ways that they understand. Oh.
Thank you. David, go ahead.
Okay, can everyone hear me?
Yes.
Good. I'm going to be very brief because we are behind schedule, and I'll just tell you the main points that I was going to make without giving you the information underneath. Maybe it'll come out a little more later. I wanted to make two main points. One is that I think likelihoods fit nicely into the conceptual framework of the law of evidence, that there is an intimate relationship between the statistical and logical concepts of likelihood and that the legal concepts of probative value. In this regard, I don't think that likelihood has to be tied solely to a Bayesian framework. I think Edwards, Royal, and others, we could argue about what works, but there are motivations for likelihoods being used to explain things other than thinking in terms of posterior probabilities and how the likelihood affects those. The second main point I was going to raise is that case law is, at least in the US, amenable to likelihoods, especially when presented transparently, and by that I mean with the assumptions and some of the details laid out. And there are two major areas in which that's been, in which likelihoods have been used, not necessarily using those words, but since the 1970s, for cases involving genetic relationship testing, they've been routinely used. And of course, in DNA and mixture cases, they've come in. In that latter situation, in mixture cases, now I am getting into detail, but just to pick up on a point that Bill made, I find case after case in which court opinions transpose the meaning of a likelihood ratio and of likelihoods into statements about posteriors. Nevertheless, that's also true of other methods of presentation. And so I come down on the side of thinking that the expert is fulfilling the function of an expert in law more effectively by describing the expert's views as justified to the jury and why the jury should accept those as to the probabilities of seeing the evidence under competing hypotheses. And I'll stop there. No, I won't. I'm going to add one thing. The situation, all that we heard earlier, most of it was focused on situations where we would have a score distribution for which we could talk about the characteristics, statistical characteristics of those scores. But if you look at what's going on in the pattern and impression area today, where people are also advocating likelihoods, it is going to be very subjective likelihoods. And I suppose the analogy would be to present other examiners and what their subjective likelihoods are. And now I will stop.
Thank you, David, for your brevity. As you can see, we have several questions already in the chat. So if you do have an additional question, please do type it into the webinar chat. And panelists, Steve, Hari, Hal, Bill, David, if you guys want to respond, go ahead and let us know which question in the chat you are responding to. and then that'll kick off our discussion.
Okay, this is Hal. So I hadn't read them all before. So Sam, if you want maybe to look through and see if there's some questions that you can pose, I'll react to one of them. Steve Brock asked, is there evidence that a system based on likelihood ratios is any more effective or accurate than what is currently reported using the categorical framework? And I think that's a great question. Bill Thompson talked to some extent about the work that he's been doing, and I've been helping a little bit on the analysis in terms of how juries hear different kinds of statements, likelihood conclusions versus conclusions, and they all but I think more importantly it's a great question, and it's, I think, the nature of the research that should be done. It is really, we're still now trying to fill in how accurate are people when they use categorical framework, and then there needs to be data on how accurate people are with likelihood ratios. So I'll stop there.
All right, if no one's speaking, I'll just add to what Hal said. I do think Brock's question about the accuracy of the entire judicial system, needs to be the focus. But it's very difficult to evaluate the accuracy at a systemic level. And what we're asking is are juries more likely to make the correct decision in criminal cases if the forensic evidence is conveyed to them with one, in one particular format versus another? And that's a difficult question to answer. It's difficult even to conceive of how you would design an experiment in order to test that. What we can do as social scientists in addressing the question is try to break down a little bit what would need to happen for the system to operate accurately. I mean, for one thing, we'd want people to have some understanding of the strength of the forensic evidence. We'd want them, we would expect difficulties if people misunderstood or misinterpreted the experts' statements in ways that cause them to misevaluate evidence strength. That could obviously lead to errors. So those, I think, are the kinds of things we should be looking at. And those are the reasons that I think we're particularly concerned about fallacious misuse of evidence. I mean, the danger that people will transpose conditional probabilities and think the experts talking about the probability of the hypotheses are true, when in fact the experts talking about the probability of the evidence under some hypotheses. That could conceivably lead to big errors, particularly in cases where the other evidence in the case strongly supports one hypothesis or the other. So we can identify danger zones. But I think evaluating the overall accuracy of the system is more than we can do at this stage.
So there's a few different questions from Steve Brock here, trying to parse out a subset of those to respond to. One of the statements is that transparency is important so demonstrate the data that is present, as opinions must be supported. However, the jury members do not possess the specialized knowledge that allows them to interpret the data that is present. That should be left to the analyst. And so I personally, and I think Hari personally, are not convinced that the methods that information might be presented to a lay audience have been sufficiently explored. And we feel like there may be a general mischaracterization of the specialized knowledge that one has leading to a particular interpretation. Right, so maybe the common perspective is somebody who's interacted with data a lot is effective at choosing the appropriate model for interpreting that data. And our claim is that somebody who has interpreted data a lot is familiar with a broad set of models that one could use to interpret a given set of data, and has some tools for identifying which of those are reasonable, but explicitly does not have specialized knowledge that facilitates identifying one particular model for interpreting that data. And so that was, we're intending to communicate our perspective for that by saying the specialized knowledge of a statistician could lead to an uncertainty pyramid, but not to a particular value. That's our perspective on it.
And let me say one thing that my research group is pursuing, or we're starting to do research on now, is how people respond to expert statements where the expert is giving a range of possible values of a likelihood ratio rather than a single value. And I think we don't know anything about this yet, but we're starting to do some studies on it, and we may have some information soon.
And so. One of our questions is, it seems to us that this uncertainty pyramid exists, and so that the assessment of whether communication is effective may not be able to rely on the existence of a single value or perception that one should hold. So how do we try to justify one particular value out there, even if they don't understand a range and they can understand a particular value? Is that the understanding they should have had? Because is that the value they should have been given?
So picking a single value from a possible range of values is not within the expertise of the statistician, in our opinion. So they would be giving a single value goes outside of their expertise. Not their calculational skills, but what their subject matter knowledge allows them to do. So that would be stepping outside of their expertise.
May I interject a simple thought? And that is, using a categorical judgment is to give a single point, or one of two single points. And the problem is that if one is near the threshold of the boundary for making that judgment, how does one convey to the jury that some categorical conclusions are much more likely to be accurate than others? So we don't avoid the problem by making categorical conclusions. We just give less information.
We're not advocating for the use of categorical.
No, I didn't mean to say you were.
Okay.
That was in the question, that we have high accuracy for categorical conclusions. Why not just stick with that?
I see. So I'd like to reiterate Hal's statement that I think there is much that we agree on. And I think that's a consensus over the concern, at least with the theoretical underpinnings of offering categorical conclusions and potential risks. Of course, if we had the assessments to find out what is most effective at reaching just decisions, the theoretical underpinnings don't really matter. But I don't think anybody here advocates, or any of the panelists are advocating for use of categorical conclusions as a theoretically justified manner of communication.
Sorry to interrupt. David, you're sharing your screen. Is that purposeful? David, you're also muted.
Sorry, I'm looking for the thing to eliminate my shared screen, but that's no longer at the bottom. Sorry, I've got the launching screen showing for some reason. Did that do it?
Yes, thank you.
Okay, apologies.
I'll add to what Steve just said. This is Hal again. He nicely summarized some of the things that most of us, and certainly the panelists, agree on. And I think one of the things that I found interesting about the activity around their paper was what I thought was a very nice paper got a press release that probably overstated things or skewed things a little bit. And then people react to the press release more so than even the paper, and that there were comments about, hey, you know, statisticians themselves are questioning likely ratios, therefore we don't have to pay any attention to it. And it's I don't have an answer for what I'm about to say, but it for me has been an interesting part of the dialogue to think about, you know, the consequences of the statements we make and what we take for granted in the scientific world of, you know, free exchange of ideas and opinions and disagreeing where we disagree, and putting it all out there, you know, has consequences in an environment like this. And so that's been direction. One of the questions from Steve Brock was, you know, why are we talking about likelihood ratios rather than a Bayesian approach? And I find a lot of confusion in the forensic discussions about what's Bayesian and what's not Bayesian. And part of that is natural ambiguity, because to a statistician, anything that makes use of Bayes' rule, a mathematical result, is Bayesian. So the likelihood ratio itself is a Bayesian concept, as Steve laid out. It fits in the middle of the move from the prior distribution, from prior thoughts to posterior thoughts. For statisticians, you know, the distinction becomes a little bit, a truly Bayesian approach to all this would probably push one towards posteriors instead of likely ratios. And so, and as you heard from several of the panelists, you know, we think likely ratios are kind of where the expert ought to live, and posteriors are where the trier of fact ought to live. That's it.
There is one comment that I would like to make or reiterate, and that is the receiver of the information, the trier of fact, the jurors, need to have some basis for judging how reliable a likelihood ratio testimony is, or any kind of testimony is for that matter. It becomes very difficult for them to assess how reliable a likelihood ratio value presented by an expert is, unless they are also aware that other experts could have other likelihood ratios. And if they are all over the place, then there is no value for a single presentation of a likelihood ratio. So I think we need to also focus on how reliable that assessment is. People seem to treat it like a measurement. Any kind of a measurement has to undergo things like interlaboratory trials. How different labs perform this, do they all come to the, you know, same conclusion, same measurement? So that's something that needs to be looked at.
Hari and Steve, what do you think about the PCAST recommendations that the expert give a categorical determination, but that it be accompanied by error rate data on the showing the likelihood of error? Is that?
So I think that's one possible implementation, where we're trying to put the emphasis on what the actual information available is. So if they were to use a categorical response, to treat that just like a score, so you could map an ID to a 3, an inconclusive to a 2, and an exclusion to a 1, and now you're still going to start looking at what do you know about when threes occur or when IDs occur, when two things actually originated from the same source? What do you know about when threes occur when they did not? And then still undergo the, okay, for that collection of data that you have about when these various conclusions are reached, how relevant are those to the case at hand? You know, how do you weight your examination of those to this particular case? So I still think that fits within the framework, trying to put the focus on the collection of information that's actually available, and whether the assessment for degree of correspondence is made by an algorithm or by a human. I think we just stick with whatever has been shown to work best.
Steve, I think that's well said. Again, this is Hal. In a way, I've always thought about it as the PCAST black box approach to getting error rates basically moves the evidence. Right? The evidence is no longer the fingerprints, but the expert's testimony, the 1, 2, and 3 that you just described, and they beget likelihoods or likelihood ratio. Right? How likely is it that I would get this evidence, this testimony, if it was the same source or if it weren't the same source? So that's one aspect of it that makes some sense. The second thing that I would add to that kind of view of the world is there's a need to do how does this relate to my case? So to have some way of categorizing cases. So the handwriting project I'm in is trying to say complexity matters. The complexity of the handwriting, if you're going to make a judgment, matters. And therefore, let's try and figure out how to measure complexity and do PCAST style analyses for different categories of complexity, so that when a case comes up, I can slot it better. And you can imagine doing the same thing in latent prints or other evidence types.
Yeah, and Hari and Steve, you made the same point earlier about the need for careful consideration of the relevance of the data to the case at hand. And I think I agree with Hal, that's an absolutely crucial point.
Okay, I think we're going to wrap up. Panelists, do you have any final thoughts?
Well, I just want to thank you all for making this possible, and very good discussions and more food for thought. So thanks.
Yeah, thanks to CSAFE and to the other panelists.
Thank you all.
Thank you.
Thanks to everyone.
Okay, thank you, everybody.